So now we come to the last part. We have the panel discussion where all the presenters will come again, and they'll be joined by Sergey Dechant, the CEO of Co-Intelligence. And the panel will be led by Boris Paskalev, who's the head of product for AI code analysis at Snyk. Boris has an executive MBA from Triumph, as well as MSCs and BSCs from MIT. And since we have a tech audience, I'd like to elaborate that Triumph is in the lines of the NYU Stern School of Business, the London School of Economics, and the Heck School of Management in Paris. So a very illustrious combination there. Boris has worked at various financial and tech companies, Putnam Investments, OpenNet, and Deutsche Bank, before establishing a successful 15-year career at Vistaprint, the largest online supplier of physical and digital marketing products for small and micro businesses. In 2017, Boris co-founded DeepCode AI, the first AI for software code that can learn from billions of lines of code and extract knowledge of the global development community. Enabling AI-based detection of security and reliability code issues named Grammarly for coders. DeepCode is an excellent example of modern AI systems that can learn from data, software code in this case, yet remain transparent and interpretable for humans, aka symbolic AI. Together with his friend and co-founders, an amazing team, Boris led DeepCode from an ETH spin-off to being acquired by Snyk, where he's currently the head of product for the AI code analysis. So let's welcome Boris as the head of the panel, and you can take it from there. Welcome, Boris.
Welcome, everyone, and apologies, Matthew. I didn't know you're going to read all of this, otherwise I'm going with this.
Well, it's all interesting, so I'm glad our audience knows this.
Super. No, it's great. Great presenters, great talk. So let's come together and ask them some cool questions.
Okay.
Sergey, hello.
Hi, Boris.
So for everybody, feel free to type in questions in the Slack channel for panel or general. We'll see that as well. I have prepared a couple just so we get everybody there, and the speakers feel free to join in as you can. I think you can turn on your cameras, but just mute yourself every once in a while. I think that's the setup. So I'll start with one question just for everybody to see what they think. And we saw a little bit of an impact what each tool actually does today. And I was wondering how you envision those tools to impact the development community in 5 years. You can answer it in kind of number of developers that are going to be using the tools, or number of projects that are going to be covered by it. I'm just curious what your visions are.
Sorry, I didn't get the question. I had a few connection issues. And also, is Simon and Marina missing, or I just don't see them? So, oh, there he is.
Simon's coming. Good.
Yeah, I think how many people we have on screen at one time. And I don't seem to be able to turn my camera on, but I can turn audio on and off.
Okay, so they are in the talk here. Okay, perfect. Boris, could you please repeat the question, because I was handling those kind of issues here. But sorry.
So the question is for each tool, where do you see the tool impacting the development community in 5 years? You can say, hey, today we're covering X developers, X projects, but in 5 years, we believe we're going to be here and we're actively working towards.
Okay, so if we are saying it would be over 1,000 developers right now, but in 5 years, obviously, I see that we will move away from all those marketing terms, DAST, SAST, and so on, because I think that most of the tools or the players there will kind of make an all-in-one solution, because basically static analysis is something where you get immediate feedback in your IDE. And if you are part of the continuous integration, it definitely needs to be something dynamic. So whether it's coverage-based fuzzing or black box fuzzing shouldn't matter, but in the end, it will be on combination on that. And I mean, since you are at Snyk, there is also the software component analysis, and this is another thing. So basically, I think that most of the players will kind of have an all-in-one solution, and obviously we want to get there as well. And fuzz testing is one of the techniques making it possible, because so far dynamic analysis was too hard to use in continuous integration. But with all those kind of advancements, it will be definitely possible.
Very cool. So you're seeing an integration of all the systems together for one covers it all. And I think I want to hear Abhishek, because OSS Fuzz is pretty much trying to do that. Kind of allows many tools to be together as well. And Simon, if you think that Zap's going to be there as well.
Yes, definitely. So I think in 5 years, we would be hoping that we don't have to really spread the word on fuzzing, like it becomes as standard and ubiquitous as testing itself. So we would more likely see like frameworks where all of these fuzzing tools, fuzzing engines, like tools like Zap, or like fuzzing engines like LibFuzzer and AFL++, those are all integrated in this framework, and then people just write these unit tests next to, or like fuzzer tests next to their unit tests, and it becomes completely ubiquitous and transparent in that way.
Got it.
Thank
you. Simon, before coming to you, ladies first, Marina, just a quick question. Is Microsoft planning to actually join that and actually adding Wrestler to the OSS Fuzz?
So I don't know if I can comment on like those type of product future plans, but I will say like where I hope Wrestler gets ubiquitous use like over the next 5 years is in kind of the services deployment pipeline. So right now, this is seems from our experience, it's a very much non-standardized kind of space. So we hope that over time there's going to be like more widely used standard frameworks that fuzzing can plug in at the right time and with the right environment, and kind of package all of that together.
Very cool. Thank you. And Simon?
So I mean, how many people will use Zap in 5 years' time? Well, I don't even know how many people are using Zap right now. We're an open source tool. Anyone can download Zap. Anyone can run Zap. We get a couple of things. We get a ping when Zap starts. We get a check for update ping, but those can be disabled. And so it's very difficult to even know how many people are using Zap. We get download counts. So I know, for example, that last month we had 6 million Docker pulls. So I don't think Zap was run 6 million times, but we're talking of big numbers here. And I think you have to realize there's a difference between commercial tools and open source tools. And so commercial tools are not going to have the same reach as open source tools for a long time, if ever. And I think you also have to realize that if with fuzzing tools you have to write fuzzing test cases, that immediately cuts down the number of people who use it. If people have to do anything apart from flip a switch, then that immediately massively reduces how many people will actually use that tool. I wish it was otherwise. But so I think there's going to be, I agree with what was said before about there will be, the tools need to come together. We need to, at the moment, we've got lots of different security tools working in different ways, and there are good reasons for that. And they don't, we can't say one tool is better than another tool apart from particular circumstances, and all tools have their strengths and weaknesses. So I think we need more integration between those tools. We've already seen how the feedback-based fuzzing can really improve DAST, and having a knowledge of the source code really helps. So the tools need to come together and work together. Whether we have, there will be some commercial tools that will do everything. I don't think they're going to be cheap. So for the mass use, particularly in open source, unless the individual's tools come together and work together, we won't get that kind of adoption that we need.
Interesting. But yeah, good point. I think most of the other tools already said that they have pre-configured tools. So, and one of the measurements we're hearing is kind of how much things you cover out of the box, which is very nice. I actually do hope that actually commercial tools, there's a good trend that they're actually free for open source anyway. So even if they are so great, expensive yet for commercial use, they will remain free for open source. So I think that's a good trend there. Anybody else wants to add anything on that topic? Otherwise, I'll jump for something else. Let's see if we have more questions in the chat. Nothing yet. Then I'll throw another one that actually Touch asked in the general channel, how can we get started with the web service fuzzing? And I want to understand clearly. We actually got an answer that with if you have a definition of service and or your APIs are actually open API, you can start that quickly with Zap or Wrestler. But the question is what is the setup time required? I mean, including like if you have out-of-the-box settings that you can count that in, but in hours, how much time does it take to set up fuzzing for web application, like small size website, e-commerce, whatever that is?
Well, this of course depends on the application and the complexity of the application, but it can be done in a few minutes. And if you're talking about simple applications, like if the example we showed with WebCode, you just need the API and the API definition, and the fuzzer will just automatically understand that, and then based on that, just perform its mutation, so you can get up and running in a few minutes. And this is just based on what Simon said. This use case where you just have the API definition and you automatically generate the fuzz test, this would reduce the barriers for developers to use it, because they don't have to write fuzz tests. And so that you can get up and running in 2 minutes, actually.
Got it. And I'm assuming that that's similar for the Zap and the Wrestler tools, that they're pretty easy to set up and people can start using them immediately. Is that the case?
With Zap, definitely. I mean, we've got Docker images you can pull. We've got a desktop application. And I mean, the desktop is quite good because you can then see what's going on inside Zap. You see the site map, so you can actually, even if you want to end up automating, I always recommend you start with the desktop app so you can actually see what's going on, see Zap's understanding, and then configure it to improve it. But we have things like GitHub Actions. So you can just include GitHub Actions right now. So Zap isn't even running on your own infrastructure. So yeah, very quick to set up, but to get the most out, you still need to take time to understand how Zap understands your application and potentially tune it.
Got it. I think, Abhishek, you already answered in your presentation that it's pretty automated and everything is very nice workflow, so developers get even reminders and everything, which is pretty cool. And Marina, from your perspective, how long does it take to set up an initial run?
Yeah, so for Wrestler, it's minutes to set up an initial run. I think the biggest next step that still can take a little bit of time, just depending on what resources you already have, is setting up the authentication. So it's very flexible, but if you have very standard token-based auth, you need to have some kind of a program that does the authentication that you pass to the tool. So, it may take you 10 minutes. If you already have that, it may take you an hour. If you need to write that, if you know very little about authentication and you kind of have a service you need to attack, it may take you a day. It just kind of depends. But after that, like Simon said, it depends on how much coverage you want to get out and how complex the app is. So in some cases, we've had the authentication we can reuse, and it's 100% coverage out of the box. And those are yes, this is awesome. But it's not always like that.
So in short, everybody can start using all those tools pretty quickly. So definitely try them out. I'll recommend. Authentication problems, I think Simon highlighted, you can do it in test mode, bypass authentication. I think that's a brilliant hack, in my opinion, not to have to deal with authentication, clearly not always applicable. But that's very, very nice. So everybody, you can jump onto it very, very quickly, which is nice. Okay, so let's see questions. No questions so far. Up now I see. Wow, this is cool. Get GitHub Actions. Yes, actually, GitHub Actions was very cool. And I was surprised that you actually have architectures for Zap that's like the OSS fuzzes. Actually, you don't have to run it on your own, which is nice. Web services for everything, which is great. Okay, so just a very quick question. What tools do you actually use in your internal environment? And that's kind of a question for everybody, again, for code quality and security today. I'm just very curious. Dog fooding obviously being one of them, but what else? Nobody wants to answer that question.
I'll jump on for that.
So
we use static source code analysis for Zap. So it looks good to me. It's actually worked very well for us. We actually also have a bug bounty. So if you can find a remote code execution on Zap, and that includes via our heads-up display, then you'll get $1,000. So I think there's static source code analysis. We don't really, I mean, we have the HUD, that's kind of different interface. So we didn't have a web interface for us to test, but static source code analysis is good.
Very cool. Abhishek?
Yeah, so we encourage our security teams and developers to use the same tooling that we use internally, or the same tooling we use internally as well. So if you think of ClusterFuzz, which is fully open source, that's the same infrastructure that's used inside Google as well in all of the different product areas for fuzzing. So yeah, we do the same fuzzing engines, which are all open source, like LibFuzzer, AFL, HonkFuzz. So that's our vision, which is security shouldn't be kept confidential, or it should be always open source, shared with the community, and we should all build up on it together.
Very good. Sergey, do you want to share for Code Intelligence?
Yeah, so a fun fact, we actually used fuzzing to find bugs inside the fuzzers. So we found a few of them. So this was really nice. Yeah, and for the C and C++ parts, we use a lot of C-lang checkers, because those are as well pretty good. Yeah, maybe Khaled could share a few other things.
Yeah, so basically, yeah, regarding security testing, of course, fuzzing is a great tool there. We also perform all kind of unit testing and system tests, and because with fuzzing we can find edge cases, but you'd also like to find to make sure that we functionally everything is fine. So also, of course, static analysis for some parts. So
got it. Thank you very much, Khaled. And Marina?
Yeah, so I wasn't sure actually what the question is about, but so I'll answer it in the context of Wrestler and kind of the Wrestler-related tooling. What do we use? So I think for security, one of the biggest things we take advantage of is Microsoft's kind of static code scanning and security checks out of Azure DevOps that currently exists. And this has some components that are publicly available, some kind of more private components geared toward Microsoft. But this is great because just by checking in code, you automatically get those running, and they actually find issues on a regular basis. And so that CI/CD workflow is just huge for us. And then I think for code quality, interestingly, the biggest bug finder and kind of ongoing quality monitoring for Wrestler would be the real world API specifications that we find, and kind of the real services across the company that we just were like, well, we are hardening Wrestler for open source. How are we going to do this? Well, we're going to point it at all these, very complex API specifications that people have written. We don't really handcraft our own, both for time reasons and because, we really want these to work on, all of these public APIs out there. So that's been kind of the biggest impact for us.
Got it. Thank you very much. I appreciate some of it could be confidential, so appreciate it. And then I'll go with another question, which is recommendation to the whole audience. So now that we heard about all those tools, what would be your recommendation for next steps? We knew what the vision is going to be in 5 years. All the tools are going to be connected. But if I'm not using fuzzing today, and I'm sure some of the people in the audience might not, which tool should I start using? Do we just jump together and put them all in, or do you pick and choose?
Well, I think it's worth talking about security tools in general now, because I think if somebody isn't, if people aren't using any security tools, then it's quite overwhelming. And there is advantages and disadvantages of all of them. Personally, I'm going to say DAST is a great start, and because that is Dast is the applications, the attacker's view on your system. Things like SAST, if you're using closed source, your attackers hopefully don't have access to that, so they can't find the bugs immediately. But with Dast tools are acting as the malicious attackers. So they are doing what the malicious attackers can do, and therefore, if you don't do any, I would start with Dast. But Dast is not a silver bullet. None of the tools are silver bullets. And I think the key thing is, find out what works for you and then use that as much as possible.
Yeah, totally agree with Simon. And also one advantage of using dynamic analysis is that with dynamic analysis, you would get a proof, like for this bug, this is the input that would trigger it, so that it would give you a sort of an actionable item that you can, as a developer, have a look at what's happening there, compared to static analysis, where you have this could be something there, but I'm not sure, might be false positive. So this would be harder for developers to just accept it. Maybe after some time they would just say, okay, it's false positive, just don't bother looking at the bugs there. But for Dast, I would start with that as well.
Very good. Yes. And Abhishek, your opinion?
Yeah, I would definitely recommend using like fuzzing as a way to find security vulnerabilities and stability issues. We have quite a bit of nice fuzzers written for all the different languages. So at this point, if you are looking for, or if you have your source out in the open, like I would definitely recommend OSS Fuzz. Otherwise, if you are doing on-premise thing, we definitely have like Cluster Fuzz infrastructure, which you can run at scale, and it already supports all these tools natively. But I would just say, like, yeah, start somewhere. If you have questions, feel free to reach out. The community has developed like some really great things in the fuzzing space. And I would say fuzzing is definitely very useful because there is almost like zero false positives there. Like it's all dynamic runtime stuff. So it can be very well automated. It's mostly automated. So that's the advantages of it. You can scale it pretty easily. So to give you an example, like OSS Fuzz, we don't have to do management of those 400 projects. It cannot scale with a team of any size. But it all works because the flows are all automated.
Oh, no, it makes sense.
And one big thing, yeah.
Sorry, go ahead.
One big thing I want to really stress out, which I think a lot of the other speakers have mentioned too, it should be continuous testing. Like no matter what you do, you have to make sure it's in your continuous development workflows. It shouldn't be a one-time thing because that doesn't work and you will have regressions every time.
So I will say one caveat to what I said before, and that is if it's a completely new project where you're starting a new code base, then get static code analysis in there right at the beginning. If you're applying static SAS to an existing code base, it can be a nightmare because you get a huge number of findings and just triaging them is hard. But if you're starting from a clean slate, static code analysis, keep everything as clean as possible, and it'll make things so much easier for you.
Yeah, fair point. But yeah, dynamic is, those are all 0 days, right? Because if you can find them, the attackers can find them. So it's a good point. Mariana, you're on, so go ahead.
So I agree with everything said so far about fuzzing. I just want to add one point. If you've done like no fuzzing and very little kind of a security assessment, I would start with doing like some kind of attack surface analysis, and then just try to fuzz like the one, very critical target if you can find it. And that just really helps you feel good about getting results. Like you may have like lots of unexplored things out there, but you're able to prioritize and really get a sense on, delivering some value quickly. So like with Wrestler, we give you ways to do like a regular expression where you can really just fuzz the one endpoint that's like the really important one. And you don't have to, wait for results or have to go through a lot of things, right away.
Sounds good. Thank you very much. So there was some questions in the panel. One of it was, what is the false positive rate of the different fuzzers discussed today? I think we answered it in the previous discussion, which is almost 0, right? That's one of the benefits of dynamic analysis, because you really have a problem and you have the exact way to actually repeating it, right? Like what you have to do to repeat it. I mean, I think Marina mentioned an example where like a crash was by design, so that you can count as false positive, but those are rare, obviously. And then another question came in. So if I was setting up a CI/CD myself, what do you guys recommend if I do want to use GitHub GitLab for CI/CD? And that's coming from NetZero.
So it depends whether it's an open source project or commercial, because for open source, obviously there is OSS Fuzz, and just go with it. If you have commercial projects, probably you are not able to use cluster Fuzz for some reasons, and then obviously you have to go for some commercial solutions to do the proper integration, or you build something yourself, but it just takes a lot of time because you have to consider how long do you run the fuzz test, when do you stop, and stuff like that. And usually if you are running something like OSS Fuzz, or in our case Code Intelligence, someone is taking care of that. So it's obviously a matter of what kind of project you have.
Yeah. And Simon already said that they have GitHub Actions directly, so definitely add them on, especially you don't need architecture, they run it on for you, so sounds good. And for OSS Fuzz as well, I heard that's the case, so it's very easy to integrate and start using it. Marina, from your side?
Yeah, just a quick note. So I didn't get a chance due to time constraints to present in detail the REST API fuzz testing toolkit that also is developed by Microsoft Research. This gives you a Docker-based environment that you can either deploy to Azure, or you can put into your own system in its local mode. And that gives you certainly optimized for Wrestler, I would say, REST CI/CD environment that we already have out there for you. It's open source, so you can try it.
Okay, super. So sounds like all tools are possible to be easily start running. And Abhishek, do you want to highlight anything for the OSS Fuzzer?
Yes, so one advantage you get with OSS Fuzz as well, which is it will execute your fuzzers at scale, but you get the CI/CD integration as well. So we have a solution where if you have signed up for OSS Fuzz service, you can also have the same fuzzers run at scale in your CI pipeline. So that comes for almost free. You just land a file and it runs with every commit you have.
Sounds good. Super, yeah. And Simon wrote how easy it is to run Zap anywhere that supports Java or Docker, of course. So with that said, I think we have less than 1 minute of time. So I'll let it open for one more question, actually, or give it back to the host to do some closing remarks, obviously. So last chance for a question, anybody? Okay, then back to our hosts.
Oh, thank you, Boris, for leading that very interesting panel discussion. Thank you to all the speakers. Yes, that wraps up our FuzzCon conference today. Thank you all so much for attending and for all the great questions you asked. I hope you took a lot away. I know I did. So yeah, thank you to all the speakers, thank you to all the audience, and thank you again to Code Intelligence for organizing all of this. It's rare for an online conference to go down with so few technical hitches, so well done to the tech team here. Thank you very much, and I wish you all a good night or good afternoon, depending on which time zone you're in. Bye.